Hello, everybody. My name is Andrei Kvapil, and today I'm going to tell you about Kubernetes, that it is new Skynet or rise of Kubernetes automation. Few words about me. Can we see my slides, please? Thank you. I started my Kubernetes experience working for Vedas. This is biggest Czech hosting company. I was doing automation for a lot of servers, hundreds and thousands of servers which were put into the oil. That was quite exciting job. I was automating the bootstrapping of these servers and running Kubernetes on top of this. Then I switched to work for Pelark. I was developing Kubernetes platform which is called Deckhouse. I bring virtualization based on KubeVirt and storage based on LinStore there. And since 2023, I founded new company, and now we are focusing on providing open source solution for making managed services. And this presentation is more about how we build platform and about open source technologies used to build this platform. My presentation can be split to 4 different parts. The first part will shed a light what the problems and what the challenges have to run Kubernetes on-prem installations. Let's have a start. Do you like to use Kubernetes in the cloud? I guess yes. But there is no cloud, it's just someone else's computer, all joke. When you're using Kubernetes in cloud, you're actually acting just with this part of Kubernetes, the user part, which includes APIs, and you don't worry about this bottom part for bare metal. You don't worry about virtualization, networking stuff, how you configure routing, how you bootstrap your servers. That's all the part is done by cloud provider. Today I'm going to tell you about this part if you would like to create your own Kubernetes cloud and if you want to provide Kubernetes as a service. When you're using Kubernetes in cloud, you usually see this scheme. When you have Kubernetes control plane, so you're acting with Kubernetes control plane and all the rest part is somehow separated. So you have separated worker nodes, separated load balancers, and what is more important, the data for your application stored externally in outside storage. This works well, so you can scale it, you can scale down, scale up by creating new nodes. You can even remove all the nodes of your cluster. The data will be stored, then externally, then create it again. Your application will start acting as it was before. Load balancers will just change in points, but finally your application will be continue working in Kubernetes as before. But how you can make your own cloud? When we're talking about Kubernetes and bare metal, usually people have few options how you can do this. The most common option which people to consider is to run Kubernetes right on bare metal nodes. In this way, you can have some bare metal nodes and you can install Kubernetes the normal way, like using kubeadm, kubespray, or K3s, any tool you can use for this. But instead of this amazing scheme, you will get this scheme where all services packed together, and it has some problems. For example, you have no convenient management for this. The updates are painful because not every application is prepared to recreate nodes to shoot it down. So you have to be prepared to this. There is also no autoscaling and no multitenancy. I would say hard multitenancy because Kubernetes was never designed to be a hard multitenancy platform. The second option, which people usually to consider, is to use OpenStack and run multiple Kubernetes clusters on top of this OpenStack, or you can use any other cloud platform which you can install locally. But in this scheme, you have also a big problem that you have another stack of technologies which you have to worry. You have to have specific infrastructure team which will support this. This is typical scheme of OpenStack, which is really difficult to maintain, to update, and to keep updated. And the third option is quite new, but I would say right now it is already, Kubernetes is already prepared to run other virtual machines and other clusters. In this way, we just throw away this OpenStack layer and replace it with pure Kubernetes. And you can run other user tenant Kubernetes clusters on top of this management Kubernetes cluster. So let's put terms. Management cluster, when I will talk about management cluster, that will mean that this is a cluster which is running on bare metal. And we also have tenant clusters, which means user clusters. They run in virtual machines on top of this management cluster. The benefits of this is same ecosystem. You can use the same tools like Helm or kubectl to configure your Kubernetes, the both of them. You have hard multi-tenancy. You can really create separate clusters, and users will not even know that they're existing in the same system. And tenant clusters have the same. They implement the same cloud pattern. So you can autoscale. You can have separate load balancer and store data externally. So your application will always prepare to be working the same way like you're deploying in the cloud. You can same way install it in tenant cluster and expect that all the features will be working. The management cluster is still a little bit different, but it is limited to specific services running on it. So we can be prepared these exactly clusters and all the services running inside of this prepared to work in this way. It is actually responsible just for a few things, for providing virtual machines, for running Kubernetes clusters, databases, and queries as a service. And this way, we decided to make a platform. Our open source platform allows you to simply swap your bare metal servers into this system where you can order every specific service you want to. It has this nice dashboard where you click and install some applications the same way you'd use, I know, Apple Store or something like this. Every application, every tile on this dashboard can be configured with UI, but after all, it is just a values file for Helm charts. So you can extend it even by adding your own applications, but it is still managed by operator approach. And by talking about this platform, I would like to explain how it works on every layer. The first layer is system layer, how you run Linux and how you run Kubernetes. And we use Talos Linux, so I'll explain how it works. The second layer is storage. We do use LinStore. This storage provides, this is also open source technology, which works in kernel. It provides really high performance, but it depends on specific kernel modules, and it requires operating system to be configured the right way. For networking, we use OVN, typical technology for virtualization in OpenStack. And for virtualization, we also use KubeVirt. On top of this, we have third layer, which installs operator, cluster API, monitoring. And the fourth layer is user-side applications, how they order managed Kubernetes and databases as a service. The second and third layer also managed by Flux CD. I'll explain you how it works. But first, let's talk about the first layer, how you can simplify the installation of the operating system and running Kubernetes on-prem. Let's switch to the second part of my presentation, how we prepare hardware and OS layer. As I told you, we use Talos Linux, and let me explain you how exactly it works. Let's say you have infrastructure. It can be virtual infrastructure, virtual machines running in a cloud, or virtual machines running on bare metal, or bare metal servers itself. It doesn't matter. If you see download page in Talos Linux, you can see that it has images for every typical system which you can just download and start using. For example, there are images for Proxmox and OpenStack, there is also more generic way for installing using ISO or PXE. You can also run it locally using Docker. So it's like kind replacement. You can even try it on your local laptop, for example. But anyway, to bootstrap the cluster using Talos Linux, you have to boot Talos Linux image on your virtual machines and your servers. How you do this is not important. Let's say you have virtual machines which are running Talos Linux without configuration, maybe a short configuration of networking. But after all, to configure every machine, Talos Linux has single YAML file. So you can use single YAML file to configure whole system and your cluster. You just have to apply it using kubectl apply. Talosctl apply. Let's see how it works. This configuration file holds few sections, actually two. Machine section, which describes specific configuration for the nodes, for every node, and cluster section, which describes configuration for entry cluster. Machine section includes such options like type of machine. It can be control plane, either worker. It has certificates, also network configuration, and disk to install. The cluster section has options to describe how you can access Kubernetes API, the same certificates for accessing Kubernetes API, and some options to configure Kubernetes components. So you have single configuration file describing how it should work, and you just apply it to the virtual machine using talosctl apply command. After you apply it, it starts working. If you want to bootstrap the whole cluster, you can use the second approach. You just generate secrets, talosctl again secrets. In output, you get YAML file, which holding all the secrets for your cluster, which is really convenient way you can encrypt it and store it in Git, for example. Out of this file, you can generate few more configuration files. For this, you run talosctl again config with secrets, and you get 3 more files. Talos config is similar to kubeconfig used to accessing Talos API, and control plane is configuration used to configure your control plane nodes. Worker as well for configuring worker nodes. Then you do talosctl apply and applying this configuration file to every node. After all the nodes configured, you run talosctl bootstrap, which starts etcd cluster and magically join them together into Kubernetes. Okay, when you applied your configuration, you might want to update some node in the cluster. In this way, you just apply new configuration the same way like you applying deployment into Kubernetes, the same way you're applying this configuration to the one of the node and run upgrade command. This node itself will take a lease, drain all the workload out of this, then shut down, upgrade the image, and turn back to the cluster. This is how it works. To access the cluster, you can use virtual IP configuration, which implements floating IP. It looks like VRRP, but it's checking its state based on etcd state. So it works only on control plane nodes. Then you use kubeconfig file to accessing this cluster, and this IP can be swapped to the node. So when you put some nodes into maintenance, it will be automatically moved to another node. Looks very simple. I guess not very, because it is new pattern, and we understand user needs because we're trying to keep user experience similar to experience they have. So we developed our own tool for which automates this, and it looks like old school Debian installation method. Let's say you have some servers. We provide 2 Docker images, DHCP server and PXE server. And we have also installation tool which called Talos Bootstrap. The nodes can be booted out of the nothing just from these 2 Docker images. So they will put it into Talos in maintenance mode. Then you use this tool for creating Kubernetes and configuring your nodes one by one. How it works? When you run this tool, it finds all the nodes you have in your data center. You choose the node, put host name, choose the disk to install, put network settings, and finally you have the same Talos configuration file, which is just applied to the nodes. Then you click next, 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 and in a while you have ready cluster just in 5 minutes. If you look inside, we ship our platform with pre-built image, which holds all the needed firmwares for every hardware, and it also includes specific DRBD specific kernel models we use. It is DRBD and ZFS for our storage, and they're also running it this way. So this part is stable base for building our platform. Let's talk about the second part, layer 2 and layer 3, the system components. If you have a ready Kubernetes cluster, you're free to use it, but you have to configure it somehow first. You have to install cert manager, CNI plugin, monitoring, all this stuff which you get used to install using Helm. And in this way, I would like to say that Talos Linux works well with FluxCD, because you can configure, describe your configuration in Git repository and just put Flux, which takes these components and installing into the cluster. Even in Talos configuration file, you have extra manifest section where you can specify that Flux should be installed and YAML, which describes your configuration for the cluster. We have a little different approach because we build platform which is box solution, and we want to make it independent to any Git repository. So we ship all the components together with the platform. How we implemented it? We let our user to install platform with cozystack.yaml, which actually creates just a container, which includes all the Helm charts needed to be installed. It's just Helm chart museum with set of charts we ship with the platform. This container also installs FluxCD, and FluxCD takes all these Helm charts and installing in the cluster. If we want to update our platform, we just let user to run new container, then Flux updates those components. Very simple. This way we deliver our storage, networking, which is multi-tenant as well, for make virtualization works, and monitoring. And now the most interesting thing, how we do managed Kubernetes service. Managed Kubernetes, we provide the managed Kubernetes on-prem, which holds all the things you get to use in cloud installations. The same load balancers, persistent volumes, and cluster autoscaler. So we use Kamaji project. Kamaji project allows you to run Kubernetes as pods, so you don't have to have specific virtual machines for your control plane nodes, and users never see their control plane nodes. It's because Kubernetes is just service, we run it as same application in Kubernetes. Kamaji can provide control planes for multiple vendors like VMware, AWS, but we use KubeVirt provider. And we use Cluster API to orchestrate this. We are going to add support for multiple clouds. But right now we provide a ready system which works just out of box with KubeVirt. So if we're talking about Kamaji architecture, there's two things which you have to think. There's actually CRs, tenant control plane, which creates set of pods holding API server, control plane, scheduler, and controller manager, and data store where it stores. Usually etcd, but you can also use Postgres with project which transforms Kubernetes APIs. So by the way, as I told you, all the applications we provide is just Helm charts which putting YAML configuration to the cluster. This YAML describes new Kubernetes cluster have to be created, and it spawns the next resources cluster, kind cluster, Kamaji control plane, and KubeVirt cluster. It also creates node group. Node group creates machine deployment, and it also creates KubeVirt machine template and KubeBud config template resources. The first one is managed by control plane provider by Kamaji. The second one is managed by infrastructure provider, KubeVirt, and the next KubeBud config template managed by Bootstrap provider, which provides and generates configuration for joining nodes to the control plane using KubeVirt. If we'll dig deeper about machine deployment resource, we can see that same similarity how it works with Kubernetes deployment. So machine deployment creates machine set, and it creates machine, and every machine is just virtual machine, which is worker for our newly created cluster. This is how it works. And as about databases as a service, we use standard operators. You can see them on the screen. So when you install some application from the dashboard, the new Helm chart is created, database object, and this object is managed by operator. For example, if we're deploying Redis, you can specify that you need new Redis database, and you specify this small amount of parameters. It creates free YAML files, like Redis failover, service for connecting to it, and scraper for collecting metrics. This way, we implement the system which allows to run managed Kubernetes, managed databases, even virtual machines, and some other extra services. What about multi-tenancy? That's also an interesting topic. We built our system to not let tenant clusters access management clusters. If you use cloud, you usually see that there are a lot of service components which acting with cloud API. For example, CSI driver or cluster autoscaler. We have these components outside, and they connecting to tenant cluster. And inside of tenant cluster, user can go outside and to access any API of management Kubernetes cluster. So when user is querying, ordering new service, it goes to your website or to your web portal or your Git repository configuration, or it can access directly the servers he ordered. And as about multi-tenancy, we implement the same pattern like Linux kernel namespaces work. First, you can create tenants nested, and by default you have tenant root, which have domain assigned, and when you create new tenants, the new subdomain get assigned to them. Inside of these tenants, every tenant is namespace, Kubernetes namespace. But there are some namespace services attached to this namespace. Those services are etcd, monitoring, and ingress controller. It is allowed to create new tenants, and you can specify specific services you want to assign to this tenant before applications will be created in this tenant. But when you create applications, they are using the same services of upper tenants. For example, you can create few Kubernetes clusters, and they will use cluster etcd and common monitoring of upper tenant. This scheme is very useful in case if you want to provide user the single Grafana, where he will see all services running in other tenants created and provided by him. So, conclusion. We got the system which allows to create environments which are highly reproducible and very unified. We always have the same kernel modules, and versions are hard-coded. So we can use it for everything, for running all the cluster services. We have simple interface for installation, which not breaking user experience. And our platform covers all the infrastructure stack which you need to build your own cloud. It is easy to extend, so you can put your own Helm charts with your icons, description, which will just put needed amount of YAML files into the cluster, and we are open source. If you want to, you can find it on GitHub. Please give us a star. I'll provide you links to Cozy Stack platform, and the technologies I was talking about is Talos Linux and Kamaji project, which allows you to run Kubernetes in pods. Final link is to Kubernetes blog, where I described how it actually works in written form. Many thanks to people who helped me to prepare this amazing presentation, and I'm ready to answer your questions. The question is, what is the main difference with D8S? Unfortunately, I don't know this solution. I can't provide you any information. I'll take a look. The second question is, you showed that install CNI using flux CD. How it is possible to use flux CD when you don't have CNI? There is a mode how to run flux on host network. There is some options how you can run Talos with host network, but we don't use this approach. Our platform ships with small bash script in 50 lines of code. It also initially installs CNI and installs FluxCD, and then it expects that all the REST components will be installed in FluxCD, using FluxCD. The next question is, can you explain more in depth the bootstrap process under the hood where Flux is being used, and what are the core components bundled in chart? I was talking about this in this slide. So Helm chart is just a tool to put YAMLs into the Kubernetes. We still use operator-based approach. We just need to combine some set of files and provide smaller configuration for the user. So we provide small configuration. We can track it. We can check it with OpenAPI spec. We can provide some description for every parameter. But finally, it creates just few YAML files, which are managed by operator. Okay. I didn't answer how the bootstrap processes works. There is small bash script. It runs creation of Flux, creation of CNI, and then we are expecting that all the components will be installed by Flux. The question is, each tenant is separate Kubernetes. No, tenant is like basic entity, security entity in our system. You can use tenant, and inside of tenant, you can create multiple applications. It can be Kubernetes, or it can be Postgres. It's not important. You can run whatever you want. You can even run few Kubernetes clusters in single tenant. Yeah, the question about DeckHouse. I was working for a company who was developing the DeckHouse, and I can explain. DeckHouse covers a little bit different stack of technologies, and DeckHouse provides platform for easily using Kubernetes, but it not covers this stack of preparing managed services. So our idea is using managed services, and we want to provide managed services for service providers. Yes, Cozy Stack can be used as Kubernetes distribution, but this is not main goal. The main goal is managed services. The question is, how's the compatibility with NVIDIA GPU support when the Kubernetes is running on top of Talos OS? To be honest, I haven't tried. I tried using KubeVirt with NVIDIA drivers, and I saw that there is some implementation for NVIDIA GPUs in Talos. You just have to build your image with specific system extension, which will put all the needed kernel modules for the NVIDIA. This is important thing to know about Talos. So if you want to customize the image, you have to build your own. You just specify needed components needed to be installed. You can even use factory Talos dev, where you check mark all the extensions you want to, and output you get the image you can boot your nodes from. And this image can include all the needed drivers for NVIDIA GPUs. What is inside? What about Kubernetes? You just install this NVIDIA device plugin, if I remember it correct, and it will work. I expect it will work as usual. Is there any other questions? Maybe in auditory? Okay then, thank you.